This is big. This is big, guys. What's up, guys? Lou here, back with another video, and things are about to get scientific right here on Unbox Therapy. You might recall a previous video in which I showed you this, what is likely the backplate for the upcoming iPhone 6s. Now, I just compared the dimensions in that video. I looked at this shell compared to the shell from the standard iPhone 6 that I have over here, but the speculation was actually relating to the material in use and what the effect of that might have on the durability of the upcoming device. Now, a lot of speculation is out there regarding this new phone and whether or not it will move to something called a 7000 series aluminum. Most people out there probably don't know exactly what that means. I certainly didn't. That's why I did some extensive research and even some fairly elaborate testing. But before I get into that, you probably noticed this thing over here. This is obviously some kind of monstrosity fabricated from the geniuses over at D Brand Skins. If you don't know who they are, you should definitely go and check them out. But this is a makeshift bend test machine, which will essentially give us a readout how much weight is necessary or how much force in a weight equivalent is necessary to actually bend these two shells. Now, these aren't the complete phones. Keep that in mind. Potentially an even more interesting test because we can actually look at the aluminum attributes and how that affects the durability of a device and why Apple might be moving to a different material. So eventually I realized that what I needed was something called an XRF analyzer. This thing shoots X-rays into common alloys and tells you what their elemental makeup is. Now, before we get into the elemental makeup of each of these iPhone shells, the 6 and the new 6S, I wanna give a shout out to Elemental Controls in Mississauga. I hit these guys up shortly after I found out about these XRF analyzers, and they were like, come on down, let's do the tests. So here's the readout for the iPhone 6 shell. Essentially what we ended up with is a common alloy. As you can see up here, the readout was 6063 from the 6000 series of aluminum. Now, this 6000 series alloy is probably the most commonly bought, sold, manufactured alloy on the planet. Some speculate it represents somewhere in the neighborhood of 75 to 80% of all alloys in use. It's fairly easily machinable, so obviously it makes sense to use it in manufacturing. It also anodizes very easily, and as you know, with iPhones and various other electronics that use aluminum, generally there's some kind of anodization that gives it its color. Looking closer at the readout, you can see the exact elemental makeup of 6063. It's mostly aluminum, 98.94%, with a tiny bit of iron, a little bit of silicon, and a little bit of magnesium. Essentially, this is mostly the abundant element aluminum. So this 6063 aluminum is used in so many applications that you're probably familiar with: windows, doors, automotive. The only possible problem with this material is that it bends a little bit. As you know, you've witnessed in previous videos, it's not the strongest type of aluminum. Okay, so there's the reading on the iPhone 6, the old shell, which we know has been prone to bending. But let's go ahead and look at the report for the new one. Now, this is where things get interesting. First things first, the alloy has a much thicker anodization. Before taking our reading, we actually had to sand off that anodization to get a clear reading of the aluminum itself. We did the same for the older shell, but sanding this anodization off proved to be far more difficult, implying that it's a much thicker coating. Now, under the X-ray, under the gun, what's gonna stand out and what's important on this list is not the aluminum, that's at 91.174% of the makeup, but the zinc. Now, we took a number of different readings on this component, and each one came out a little bit different, but essentially, we always had this significant presence of zinc, which points to 7000 series aluminum. The addition of zinc here improves the strength of the material. Okay, so why did Apple change? Was this bend gate thing really as small of an impact as people were speculating? Or maybe it affected more devices than we even know? Bottom line is this: they've selected 7000 series now, they've reinforced it in specific regions, and ultimately, the expectation would be that we're going to see less bends in the next version than we saw in the previous. But it does come at a cost. With the addition of zinc, we are also going to increase the likelihood of corrosion. Nobody likes corrosion. And that is what leads me to believe that they've gone with a different anodization process. They've increased the amount that's on the surface. Now the next drawback of 7000 series aluminum, expense. This stuff is way more expensive for a number of reasons, but it mostly has to do with the availability. This is about to become a lot more common, but in the meantime, the likely effect is that the cost of production for an iPhone could go up. This new material could cost as much as 5 times more. I think it's fairly safe to say that this is going to be a little bit more labor intensive to get out in volume when compared to the 6000 series construction. But the real question here is, how much stronger? Is it all worth it? So beside me, as mentioned earlier, I have this crazy contraption which is going to measure force applied to each of these units. And I'm gonna go ahead and find out exactly how much stronger this component is, as it is the backbone for the upcoming iPhone. So let's go ahead and start with the iPhone 6 shell in order to get our baseline. Now the reason you're already seeing a reading on the scale here is because this top portion of our contraption is on top of the scale itself. If I lift this up, you'll see it comes down to 0 pounds, 0 ounces. So when considering the total amount of force that's applied to the actual units, we essentially need to start with the weight of this component itself. So the moment that I insert this shell, we're starting at a point of 2 pounds, and in this case, 10 ounces, 10.2 or 3 ounces. So this is the old shell. We've now added the additional weight of the actual shell. Now let's go ahead and slowly apply some pressure to this. Now keep an eye on that scale. We're now approaching closer to 20 pounds, 19, 24, we're just under 30 pounds of force, and we are completely bent there. You can see here at the volume buttons, in that weak spot, at about 30 pounds, we are bent. Now I'm gonna go ahead and remove this really quickly. Both sides, on the 2 obvious weak points, as we've known previously, near the power button, as well as near the volume rocker, we have weakness and we have a bend. A representation of not just the bendability of the material, but also those weak points that I mentioned in the previous video. But what happens if we increase the pressure even more? Okay, so we're right back at 30 pounds there. You can see it's starting to bend. By 32, it's really having difficulty. And by, I don't know, let's say by 35, I mean, it's indistinguishable. Essentially, you have significant bending at 30 pounds of force, and anything beyond that, the shell just begins to crumble significantly. It's interesting, in this particular case, we have a bend right across those 2 weak points there. Now it's time for the 6S backplate, the thing we've identified as probably from this 7000 series of super strong aluminum used in aerospace and now potentially used in your phone. So let's go ahead and do the same thing. So there we go. Of course, the measurement hasn't changed much here because the shell doesn't weigh very much itself. So we're gonna go ahead and start to tighten it down. Now, the magic number here, as you know, is 30 pounds. We wanna see what happens at about 30 pounds of force. We're getting close. We are at 31 pounds, over 31 pounds, and it's not significantly bent yet. Let's keep going here. 36. Wow! We are at 46 pounds now. 53. This is getting tough to twist now. 60 pounds of force. 70. The old phone, the entire phone bent at 70 pounds of force on the previous version. 80. I can hear it bending now. 80 pounds, wow. 80 pounds was the number, guys. I'm gonna go ahead and remove this now. 30 and 80. That is a huge improvement. Wow. Did not expect it to be that much stronger. Of course, they're both bent now, and they still bent relatively in the same locations. What you will notice here, though, the power button, the power cutout on this one, untouched compared to the old device, right around the interior of the volume buttons where there was that weak point. Not exactly where it bent. It bent below there, but not with as much aggressiveness as on the old one. And we were applying more than double the amount of force. This is pretty damn impressive, guys. Honestly, beyond what I expected to find. Not only do we have evidence here that this is made out of 7000 series aluminum, but now we understand the impact of that. The impact of that is a phone that will be more than twice as strong as the previous version. Is this a win for consumer reporting? When the Bendgate video came out, I didn't really understand the magnitude of it, but what this looks like is that everybody who picks up the next version of the iPhone is gonna get something that's extremely strong, and that video might have something to do with it. So there you have it. Hopefully you guys enjoyed this content. If you did, make sure to leave a thumbs up down below, or you could do one better and share this video with anyone you think would find it interesting. Shout out to the 2 companies who helped out with this. There's actually 3 total people who helped make this video possible. So you've got Sonny Dixon, who hooked me up with the shell for the upcoming iPhone, the iPhone 6S shell. You've got D-Brand, who built this crazy contraption. I'll link them down below so you can check out their skins for all kinds of different devices. And then, of course, Elemental Controls, who came out of nowhere to bring the heat with the scientific data. Amazing stuff. This is really a next level type video. I hope you guys appreciated it. We had a lot of fun making it. So there you have it. I guess you're a little bit smarter. I know I am. Thanks again for watching, and I'll catch you on the next episode. Subscribe for more videos like this. Later, guys.